Databases hold data in structured tables. And database management systems are some of the most important, heavily used, and interesting large software applications there are. Organizations spend a lot of money on their database management systems, and there are also wonderful open source projects. And the way a database organizes the data that it contains is through tables, which are collections of records. These records are rows in the table, and they have a value for every column in the table. So what would be the records in this table? Well, there's one for Berkeley, one for Cambridge, one for Minneapolis. Those are the rows or records. The columns describe information about those places. So here's a table, columns and rows. A column has a name. So this is not a record at the top, this is just the name of the columns, and the name of the column tells you what attribute of the record is contained within that column. Simple enough. It's also typically the case that there's some type of value associated with each column, so these are all strings. A row has a value for each column, and the structured query language is perhaps the most widely used programming language. It is a programming language to generate new tables out of existing tables, and then to manipulate their contents, adding and removing rows, things like that. SQL, or SQL, is a declarative programming language. In SQL, and also in other declarative languages like Prolog, a program is a description of the desired result, and the interpreter figures out how to generate the result. Imperative languages, by contrast, have programs that are descriptions of a computational process, and the interpreter carries out the execution and evaluation rules for that process. And so much of this course has been about anticipating what the interpreter is going to do when you write a program. But that's actually trickier in declarative languages. In SQL in particular, there may be multiple ways to actually carry out the computation needed to compute the result that's described by a SQL query. And the database management system will often try to choose the fastest one that would work, but that will depend on the data. So that does change the relationship between the programmer and the program evaluation, because things might be less predictable. But writing the program tends to be less work, because you don't have to describe how execution and evaluation will be carried out. That's up to the database management system. Okay, so here's another example of SQL. How do we get the tables in the first place? Well, normally they are built up through some process, like some other application, logging information or somebody typing it in. But it is possible to create a table from scratch using the structured query language. So I'll teach you how to do that just so we have something to start with, but just creating this table from scratch is not the main event here. The interesting part of SQL is what happens when you already have some tables and you want to compute some novel results. Okay, so if I want to create a new table from scratch, I can use the create table statement, which gives the table a name, cities, and then I can write select and some constants. Here, 38 is going to be one of the values in one of the columns. As tells you the name for that column, and the commas separate different columns. So this select 38 as latitude, 122 as longitude, Berkeley as name would create a one-row table that looks like this. Notice that Berkeley is in quotes because it's a value, whereas name and longitude are not because they are names of columns. Now, creating a one-row table is not that useful. We'd like multiple rows. You can do that with union, which takes a description of another one-row table and puts it together into a two-row table. And you can union multiple times in order to, for example, get a three-row table. Like I said, this is an uncommon way of building a table that would only show up if you're really starting with nothing, whereas most databases already have a bunch of data in them that came from somewhere. The interesting part is what happens when you do something with the cities table. Here, we select from cities, that's the cities table, but we only want some of the rows. Those with a longitude greater than or equal to 115. Those are the ones on the west coast of the United States. And we're going to add a region column with the value west coast for those. And name actually refers to this name. If I union that with a table full of all the other rows, the ones with a lower longitude, I end up with a table that has a region column, a name column, and tells us which are on the west coast. And by the way, this is the Massachusetts Cambridge, not the England Cambridge. You can tell by the latitude and longitude. So the interesting characteristics of this bottom query are that we selected only twice, but we got 3 rows. Well, that's because this actually described 2 different cities. And the data from the cities table was used to construct this new table. All these names came from here, and these values came from inspecting the longitude of the rows of the original cities table. This might not seem exciting, but being able to manipulate data in this way is incredibly useful. So we will now learn the details of the SQL language so that you can see the breadth of things that it's able to do.